Yes, children. We started with monosaccharides in the previous lecture. Okay. Monosaccharides are of two types, aldoses and ketoses. Aldoses are those which have an aldehyde group, and ketoses are those in which there is a ketone group. Okay. And the simplest aldose is an aldotriose, because what are carbohydrates? Carbohydrates, they are polyhydroxyaldehydes or ketones. So at least a minimum of 2 hydroxyl groups honi chahiye, right? That is why a triose is the simplest one, or the first member, you can say. It is an aldotriose. What is that? It is glyceraldehyde, because there are 2 OH groups and 1 CHO group. Okay. So it is an aldotriose, aldehyde containing compound which is having 2 hydroxyl groups. And the simplest ketotriose is dihydroxyacetone or dihydroxypropanone, where you have 2 hydroxyl groups and 1 ketonic group. Okay. So this is the simplest aldotriose. This is the simplest ketotriose. Okay. Now let us go further. Now here you see there is one chiral center. Right. What is a chiral center? A center which is surrounded by 4 different groups: OH, aldehyde, hydrogen, and CH2OH. All the 4 are different. Then only this carbon is called as a chiral center. Exactly, a asymmetric center. Asymmetric. There is no symmetry with respect to the groups that is attached to this carbon. That is why it is called as an asymmetric center. It is also called as chiral center. Okay. Now, let us go further. Again, the same glyceraldehyde I have given, and here I have written D. Now what does this D represent? This D represents the position of OH group to the asymmetric carbon. Okay. This is the asymmetric carbon, and there is only one asymmetric carbon, and the position of OH group is going to decide whether it is D isomer or L isomer. So if the OH group is to the right, then it is called as a D isomer. And if the OH group is to the left, then it is called as a L isomer. Okay. Now this D-glyceraldehyde and L-glyceraldehyde, they are non-superimposable mirror images, is it not? And such non-superimposable mirror images are called enantiomers. We have already studied about this in the first chapter, organic first chapter. We have already done it, right? Now, how many chiral centers are there in this? There is only one chiral center, okay? And how many ever chiral centers are there? You can find out how many stereoisomers we can write. Now, if there is one chiral center, there is a formula to write the number of stereoisomers possible. That is given by the formula 2 power n. Now, what is this n? N is number of chiral centers. If there is only one chiral center, so it is 2 power 1. So there are only 2 isomers possible for this. Now, supposing you take a 4 carbon chain, 1, 2, 3, 4. Okay, it is the next higher member of aldehyde, glyceraldehyde. Okay. Now, in this you find there are 2 chiral centers. This is one asymmetric carbon. This is another asymmetric carbon. And if you take the mirror image of this, it will be like this. You know to write the mirror image, is it not? Whatever is on the right, it will be on the left in the mirror image. And whatever is on the left, and that will be on the right in the mirror image. Okay. So these two are again non-superimposable mirror images of each other, and they are enantiomers. Now, how many chiral centers, asymmetric centers are there? 2. Okay. What I said, 2 power n is the formula to find out how many stereoisomers are possible. So if there are 2 asymmetric centers, so 2 power 2, how many isomers possible? 4 isomers possible. Now see how I have written the 4 isomers. One is taking OH group of both the asymmetric carbon on the same side, and in the other one I have taken one OH is on the right and one OH is on the left. Okay. Now what is the mirror image of this? Mirror image will be like this. So a total of 4 isomers are possible. That is why it is 4. Right. So how many ever asymmetric centers are there? 2 power n times stereoisomers are possible. Okay. Now let us come to the next one. that is glucose. Now this is glucose. Now how do you write glucose? Just see. See, you're starting, your lowest position, it is resembling glyceraldehyde. That is the base, okay? In the glyceraldehyde structure, how you wrote? CHO, CHOH, CH2OH. This is how you wrote glyceraldehyde. So this part is same. See, this part is same, okay? And OH is to the right of the first asymmetric carbon, the lowest asymmetric center. Is it not? The lowest asymmetric center from the bottom, whichever is the first asymmetric center, to that asymmetric center, if OH is on the right, just as the same as that of glyceraldehyde, then it is called as D-glucose. Just like D-glyceraldehyde, this is called D-glucose. Okay. And what about the rest of the things in the case of glucose? The first lowest asymmetric carbon is having HOH. Then the next one is also HOH. Now you can say fourth from the bottom or third from the top, it is OHH. Okay, you'll have to remember like this. There is no other go. And then HOH and then aldehyde group. So this is your D-glucose. D is based on the position of OH at the lowest asymmetric carbon. Right? Now, why did I write plus here? I'll come to it, just wait. Now, this is your D-glucose and the mirror image will be like this. That will be L-glucose. Whatever is on the right is on the left and whatever is on the left, it is on the right. Okay. So what is this type of arrangement called? This was given by the scientist by name Fischer. So it is called as Fischer arrangement. And you know very well glucose is an aldohexose because it's made up of 6 carbon atoms. Right? Okay. Now what is the role of this plus? Okay. Now this plus tells you what is the ability of this compound to rotate the plane of polarization of light. Does it rotate it to the right or does it rotate it to the left? That will be denoted by this plus or minus charge, which is put along with D. So D has no role with respect to optical rotation. Only this plus sign or negative sign, that is going to decide what is the direction of optical rotation, is it not? How the plane polarized light, whether it is rotated towards the right or left, that is decided by this sign. Now in this case glucose, how many asymmetric centers are there? See, there are 4 asymmetric centers. Now if there are 4 chiral centers, asymmetric centers, then 2 power 4 stereoisomers are possible. I told you number of asymmetric centers, 2 power that number stereoisomers are possible. So 2 power 4 means there are 16 stereoisomers possible. Out of the 16, this D-glucose and L-glucose are 2. Okay. Out of the 16, 2 of them are D and L glucose forms. And the rest of the 14, you need not have to study all these things. You're very fortunate. So just understand that how many stereoisomers are possible and on what basis you find out that. Okay. Now let me tell you again about plus. This is very, very important. This D plus glucose, this plus tells you what? That the molecule is dextrorotatory. That is, it rotates the plane of polarization of light to the right. Okay. And if I write D minus glucose, that means the molecule is levorotatory. Is that clear? But the glucose that is available, it is D plus form only. There is no D minus glucose. Is that clear? What is naturally existing form of glucose? That is D plus glucose only. There is no D minus glucose. Okay, if you write it as D minus, then only with respect to this OH will be on the left hand side. Is that clear? But if you take the full mirror image, then it is called as L-glucose. Right? If you change only this position, then it is called as D minus glucose. Okay? But if you completely change the whole set in terms of mirror image, then it is called as L-glucose. Okay? So remember, This D and L has nothing to do with optical rotation. It only tells you the absolute configuration, that is position of OH group to the first chiral carbon or the lowest chiral carbon. That is what is given by the term D or L. Okay. Now this first chiral carbon, when I say, remember we are taking glyceraldehyde as the base. So the first two, this is this is obtained from glyceraldehyde. Okay, this is telling you whether it is D or L. Okay, so for assigning the configuration D or L, the lowest asymmetric carbon is considered. Okay, now same way for fructose also you can say, this is fructose, it's a ketohexose. This is also having the same molecular formula C6H12O6. It is a ketohexose. That means there is a ketonic group, and ketone group cannot be at the top. You know it very well. Okay. So it is at the second position, and look at the way it is written here. Again, this part is same, is it not? But then even though OH is on the right, OH is on the right tells you it is D. OH on the lowest asymmetric carbon tells you that it is D isomer. And this minus tells you that this D fructose is rotating the plane of polarization of light to the left. Okay, so it is D minus fructose. So D minus fructose, it is levorotatory. It rotates it to the left. Okay. Now you have preparation of glucose. That is quite simple. That is also given in your textbook. Sucrose on hydrolysis can give you glucose and fructose, and starch on hydrolysis can also give you glucose. Okay, this is called a starch. C6H10O5 N times. It's a polysaccharide. It's a polymer. But sucrose is a disaccharide. So both on hydrolysis you can obtain glucose.